Very good morning to all of you friends. Today we are going to study about chapter number 13, that is motion and time, and our today's topic is about the different types of motion, that is uniform motion and non-uniform motion. Okay, this is our topic today. Now motion, we have already studied that motion, a body is said to be in motion when it is its position is changing with respect to time and surrounding. Okay, when the position of a body changes with respect to time and surrounding, then that particular body is said to be in motion. Now this motion, like for example a bird flying, okay, or a car moving on a road, or if you are walking, so these are all examples of motion. Now motion can be of two types: uniform motion and non-uniform motion. Okay, now let us see what are the characteristics of uniform motion and what are the characteristics of non-uniform motion and how they are different from each other. Now motion is of two types: uniform motion and non-uniform motion. Uniform motion means when a body is said to travel equal distance in equal interval of time. Okay, equal distance in equal interval of time. So this is the first characteristic, that a body travels equal distance in equal interval of time. Interval of time means, like, the first second it goes to a particular distance, suppose 5 meters. Second again 5 meters. Third second again 5 meters. So in this way it covers equal distance and in equal interval of time. That is why the distance and time, they are proportional to each other. We are studying about speed. That means speed has got two factors, that is distance and time. So in case of uniform motion, the distance covered is equivalent, or you can say it is proportional to time. Okay, that means equal amount of distance is moved in equal interval of time. So if we try to express it in terms of graph, all of you please look carefully. Now if this is a graph, suppose this is the distance, okay, distance traveled in this direction, and suppose this is the time. So if you divide the time, suppose this is 0, so 1 second, okay, 2 second, 3 second, 4 second, 5 second, and suppose here 5 meters, okay, 10 meters, 15 meters, 20 meters. So equal distance in this way. So a car, suppose a car, okay, moving along a straight line. Now what will happen? It will move, suppose 5 meters in first second. Then it will go 10 meters. The next 5 meters it will travel again in equal interval of time. That means 1 second. Okay, so next 5 it will go again in another next second. That means here again the next 5 meters it will cover in the next 1 second. So in this way, when we plot the graph, we see that it is more or less equal. Okay, that means in the first 5 meters, okay, the first 5 meters, suppose it has traveled in the, suppose this is t, it has traveled in the first second. That means time. Then the next 5 meters it has traveled in the next second. Then again next 5 meters it has traveled in the next second. So in this way, see, every 1 second it is going 5 meters only. That is why it is called uniform motion. So every second, 1 second, it is going 5 meters only. Okay, that is why this is called uniform motion. So once again, uniform motion means a body is said to have uniform motion when it travels equal distance in equal interval of time. In case of uniform motion, the speed is constant. Okay, here it is constant. So the speed is constant. So it is moving at a rate of 5 meter per second. So this is the speed, 5 meters every second it is going. So it is moving at a constant speed. Okay, and in such case, that means in case of uniform motion, the distance and time graph is a straight line. So the distance time graph is a straight line. Now let us see how is uniform motion different from non-uniform motion. Let us see how. Now in case of non-uniform motion, we will plot a graph and see that a body is said to be in non-uniform motion when it travels unequal distances in equal interval of time. Unequal distances means, let us see by the help of this graph. Suppose again 0, first, second, or let me write this time. Time is in terms of second. Okay, so first, second, third, fourth, fifth seconds. And this is distance. This is the arrow. Distance is in terms of, suppose, meters. Okay, so we have, this is the distance time graph. And suppose 5 meters, then next 5 meters, that means 10, the next 15, then next 20, then suppose next 25. Okay, in this way we have plotted the graph. Now suppose a car is moving, the first 5 meters it has got in the first second, suppose this way. Then suppose the next, suppose 12, that means from 5 to 12, suppose next 7 meters it has gone in the next second. Then suppose this is 12. Okay, that means 5 to 12, it has this distance it has covered in the next this time. That is why we plot it here. Then again, instead of coming to 15, maybe now it has covered the from 12 to 20, that means the next 8 meters it has traveled, suppose during the suppose third second. Okay, and then again suppose 3 meters, that means 23, it has traveled in the fourth second, suppose here. So in this way you see it is not a uniform graph. Okay, because the distance is not uniform, the distance is unequal in every interval of time. That means a body is said to be in non-uniform motion when it travels unequal distances in equal interval of time. Okay, time is equal 1 second, but here the distance is becoming unequal. Instead of 5 meters every second, it is sometimes going 3 meters, sometimes 8 meters, sometimes 7 meters. So in this way it is unequal, distance is unequal. That is why the graph is also unequal. Okay, now this graph can also be of different types. In case of non-uniform motion, the graph can be of different types. For example, this is one way of drawing the graph. Some other ways maybe, let me write this side once again, so that it is easy for you to understand. Now let me draw this line, distance lines once again. Again 5, 10, 15, suppose 20, 25. Now sometimes the graph can also be like this. Okay, let me see, unequal. First here it is going, then the next 5 meters it is traveling in 2 seconds. Okay, 2 seconds, not 1 second. Then the next 5 it is traveling in the next second. Again the next 5 it is traveling in maybe 2 seconds, very less, that is just a few, 4.2 here. Okay, so it is unequal, the distance traveled is unequal. That is why we are getting unequal type of graph. Okay, it can also be of different types. For example, it can be like this also, like this also. So we will plot it like this. So it is unequal. Again very near here, again here. This is more, but this distance is less. Okay, again there is retardation. So it can be of any type, but not a straight one. It is not like this. This kind of graph is obtained only in case of uniform motion. All the other types of graphs are non-uniform motion. Some other types of graphs may also be there, like curved, okay, or different other lines, for example, like this. So this is also a straight line, but see, it is not uniform. That means if I again plot it like this, see, it is not at all uniform. So this distance is very less, this distance is more. So it is not a uniform motion. Again we can draw another line. For example, suppose it is like this. Okay, here also we will see the distance is very less, but the time is very much more. So this is also not very uniform in nature. Okay, so we can call such kind of graphs to be non-uniform, because in case of non-uniform motion, the body moves unequal distance with equal interval of time. That means unequal distance with equal interval of time. Time is equal here, but the distance is unequal. Also, such kind of motion are said to be non-constant motion. Okay, the body does not move with a constant speed, and in case of the distance time graph, the graph is not a straight line, but it can be any curved line or any other type of line. Okay, so that is the difference between uniform and non-uniform motion. Now, one more graph I can show you, that is, you will see in your book. That's this graph. Okay, in this graph, see, distance is same. Okay, distance is suppose 0, 5, 0, 5, suppose 10, 15. See, the body is at 10 meters only. This is the distance. So the body is at 10 meters. But the time is changing. That means time is changing, but the body tends to remain at the same place. That means this body is said to be at rest. Okay, because time is moving, time is increasing, but the body is not the position of the body is not changing. That means in this case the body is said to be at rest. Okay, at rest. And these are the different types of graphs which are related to the distance time graph in case of uniform and non-uniform motion. Okay, now we will study about these graphs. You go through the book, and if you have any doubts, you can call me, as well as I will upload the summary. Please go through it and try to understand the difference between uniform motion and non-uniform motion. Thank you so much for watching this video.